Welcome back, folks, and in this video I'm going to go through the solutions to the IB Economics Higher Level Paper 3. This is the October/November 2022 paper. Now, I kind of like Paper 3. Paper 3 is one of these ones where I feel if you know exactly what you're doing, then you can pretty much get like 100%. You can do it very quickly, bang, 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 and you can get the job done. Having said that, if you don't know what you're doing, like if you don't know exactly what you're doing, then you're kind of a little bit out of luck with Paper 3. Because you can't really sort of fluff your way out of this, right? It's not like the first, couple of papers 1 and 2, I think, even if you don't kind of super know what you're doing, you can still sort of, this and that, a bit of this, bit of that, add some salt and pepper, and you can sort of bluff your way through it. But with Paper 3, it's not like that. Paper 3 is very sort of computational based. It's quite theory heavy, and if you don't know, as I say, if you don't know what you're doing, you probably got very little chance. But if you do know what you're doing, you know exactly what you're doing, you've got a really good chance of just getting a good result from this paper. So, yeah, you guys are in the right place. So hopefully, by the end of this, you'll have a better sense of what you have to, what needs to be done, and you're going to be in that position, that strong position where you can get like a really good outcome. Okay, so enough waffle. Let's have a look at some of the questions that we have to do for Paper 3. Now, you only have to answer one question. So down here it says answer. Oops, gone a little bit too far. Answer one question, and answers must be written in the answer box is provided. So I'm going to go through the solutions to question 1 in this video. I'm going to do question 2 in the follow-up video, but for now, let's just do question 1. Okay, so let's dive into it. So what do we have here? So Best Meals is one of many small catering companies, each of which prepares a variety of different meals for airlines in country X. Table 1 shows the costs of production in US dollars on a per hour basis for Best Meals. Okay, so I've got this table, and down here we've got the different number of meals that they can prepare per hour. So these are like the different quantities or the different levels of production. So they can do 14 meals per hour, 15 meals per hour, 16 meals per hour, etc. And then in the next column, we've got the average cost in US dollars. And then we've got the total cost in US dollars, and then in the final column, we've got this thing called marginal cost. So the way you read this table is that you would say, look, for example, if they were doing 14 meals per hour, it would cost them $7.25 on average per meal, or a total cost of $101.50 for those 14 meals. If you go down to the next production level, let's say if they were to crank out like 15 meals per hour, we know that's going to come in at a marginal cost of $6.50, but we don't know the average cost and we don't know the total cost. And finally, if this company is doing 16 meals per hour, that's going to come in at an average cost of $7.19 per meal, but we don't know anything else. Great, so we have a partially completed table, and it's kind of useless at this point. But believe it or not, based on this partially completed table, we can actually kind of reverse engineer and work through little bits and pieces to actually recomplete this, or recompile or reconstruct this table, as it were, which is exactly what we're going to have to do in the first part of this question. So part part 1, we have to determine the missing cost figures and insert your answers in table 1. Great, so got a whole bunch of unknowns, right? So question mark, right, question mark. How on earth are we going to figure out all these unknown bits and pieces? Okay, I'm going to start with this first one over here, where we've got a marginal cost of $6.50. What is the marginal cost? Well, the marginal cost is the change in total cost. So as we go from one level of production to another, that's the change in total cost. So in this case, in this example, were we to go from 14 meals per hour to 15 meals per hour, the marginal cost, the extra cost of producing that 15th meal would be $6.50. Now, the total cost of doing 14 meals is $101.50. So if I do 14 meals, it's going to cost me $101.50. And if I do 15 meals, We don't know what it is, but we know it's going to be 101.5 plus an additional marginal cost of $6.50. So to figure out the total cost at 15 meals, we simply go $101.50 plus $6.50. Well, that's going to give us a total cost of $108. So that's how we can work out this first bit over here at the total cost at 15 meals, and that's going to be $108. Great. So from here, we can actually work out the average cost at $15 at 15 meals per hour. Because the way we work out average cost is defined as total cost divided by the quantity. So in this case, I'm going to do 108 meals. Sorry, I'm going to do 15 meals, and it's going to cost me $108 in total. So on average, per meal, that's going to be $108 divided by 15. So if I go 108 divided by 15, that's going to give me an average cost of $7.20. So let's plonk that in over here. Oops. So $7.20, great. And now moving on to the last row, here we're told that if we do 16 meals per hour, that's going to come in at an average cost of $7.19. The total, so here we're saying that each meal is going to cost us $7.19 on average, but we're doing 16 meals. So to figure out the total cost of those 16 meals, we now go the opposite. If I go $7.19 multiplied by 16, that should give me my total cost. So let's go ahead and do that. So I'm going to go $7.19 multiplied by 16, and that's going to give us a total cost of $115.04. So we got 115.04, or you can go, well, what did I say? It was 04, beg your pardon, not 40. Great. And was that what it was? Yeah, that's right. Okay, and so the final bit, the marginal cost. Well, let me just rub this out. Okay, so as I go from 15 to 16 meals, my total cost is going to rise from 108 to 115.4. So that's going to be a marginal cost, right? That's going to be a delta of 115.04 minus 108, and that delta is going to be 7.04. So we're going to go $7.04 for the marginal cost of producing the 16th meal. So there you have it, right? Even though we only had this partially completed table, we were able to recover the entire thing just by doing a bit of algebra and using the knowledge using our knowledge of marginal cost and total cost, etc. Great, so that's this part done. Now let's move on to the second part of this question. Assuming that the catering market is in a long-run equilibrium, sketch a diagram in which the profit maximizing level of output for a firm in this market is shown. Okay, so this one's a little bit tricky. I wouldn't say tricky, but it's just gotta know what you're doing. Okay, so to begin with, let's label the axes, because that's always a good thing. So it's something like price and I guess quantity on the horizontal axes. Okay, now we're gonna start by drawing a demand curve. So this is our typical demand curve. I'll label it, actually, no, I'll use a different color. I'm gonna use blue. So this is our demand curve. I'm gonna label it like D for demand. Now, from here, I'm going to insert this thing called a marginal revenue curve. Marginal revenue has the same intercept as the demand curve, but it has twice the gradient. So the way we would depict that graphically is we would sort of imagine you have the same intercept. So we're going to nail that intercept into its place. But now we're going to rotate that demand curve like 50% inwards, and that's going to give us the marginal revenue curve, or the marginal revenue function. By the way, if you don't know what I'm talking about, if all of this seems foreign to you, then you need to go back and do a revision, because I'm going to assume moving forward that you kind of sort of already know what we're doing here, or at least you've got some idea as to what these curves represent. Next, we're going to have to insert this thing called a marginal cost curve. Now the marginal cost curve is going to have this kind of upward swoosh kind of shape, kind of like the Nike symbol, right? So kind of go upwards like this. I'm going to call this MC for marginal cost, and that's going to represent the cost, the extra cost per unit of producing those extra units of whatever this thing that we're making are, right? So marginal cost curves typically have this upward shape. Next, we're going to identify the profit maximizing output level. Profit maximization will occur at the point where marginal revenue equals marginal cost. So that's going to be over here at that intersection between the red MC curve and the blue MR curve. And so we're going to trace out the coordinates of this this intersection. So if we trace up, if we sort of trace up to the demand curve and across the price axis, we can see P is going to be the price of this thing, and we're going to be selling or producing Q units of this thing. Okay, the next bit is a little bit tricky because we're going to have to introduce the ATC curve, or the average total cost curve, and we have to draw it so that the ATC curve is going to be tangential to the demand curve at the profit maximizing output level. So in other words, it's going to just touch that demand curve at this point over here. So gotta be a little bit, there we go, something like that, right? I'm going to label this ATC. Now, if we're in a long run equilibrium, then we're going to be producing over here. So this is where P equals ATC. And so what we're saying is that under perfect competition, the price, which is how much you receive from selling a single unit of this thing, is going to be equal to ATC, which is how much it costs on average to make a unit of this thing. So here we have allocative efficiency because what it costs to make something is what we can sell it for, right? So yeah, this is the kind of diagram that you got to draw. A couple of things to note: just make sure you label your axes properly, all your diagrams, make sure all your lines and your functions and curves, make sure they're labeled properly. I guess you can use like different colors if you want, as I have over here, just to highlight the differences, and make sure you annotate your graph. So put in your P's and your Q's and all that sort of stuff, and yeah, you should be okay. Okay, let's move on. All right, so next we have this diagram that's going to show us something to do with price controls. So let's have a quick read about the little question thingy to begin with. So here we're told that the catering companies buy tomatoes from the domestic market to prepare their meals. Figure 1 illustrates the domestic market for tomatoes, which is perfectly competitive. S is supply, D is demand. Okay, so let's go down to figure 1. Just gotta get it just right. Okay, so here we go, figure 1. Okay, so we've got some kind of supply curve. We have some kind of demand, and yeah, so, and next we've got this thing called P min, which I'm guessing is going to be the price control or the price floor, which we're going to discuss in a minute. Okay, so everything pretty standard at this point. Now, down here, in order to support the incomes of the tomato farmers, the government of country X has set a price floor, P min, at $2.80 per kilogram. So that's this this thing over here. That's the price floor, the price control. Great. Okay, what do we have to do? Well, using figure 1, calculate the change in consumer surplus resulting from this government intervention, right? So the key word here is the change in consumer surplus. That's what we're going to do. We're going to figure out the delta in consumer surplus as a result of this price control. So the strategy moving forward is we've got to figure out the consumer surplus before the price control, and then we've got to figure out the consumer surplus after the price control. We take the difference between the two, and that's going to give us the change, right, the delta. Okay, so if we didn't have the price control, let's imagine this thing didn't exist, right? So we've got to zap out that P min, right? So forget that, if you can in your mind, try to imagine that that line doesn't exist. So what we're left with is supply and demand. So in equilibrium, we would be, say, at point A. Now, consumer surplus would be equal to this triangle over here, right? So that's the area between the demand curve and the market price, which is going to be, I think, $2.40 if I'm not mistaken, right? So that thing over there is going to be $2.40, and if we go down to, if we drop this thing down over here, we can see that's going to be like 16 or something. Okay, so to figure out consumer surplus, we take the area of that triangle, and to get the area of the triangle, we go half base times height. So this triangle has a base of, if we go down a little bit, it's going to have a base of 16. So that base is going to be 16, and this vertical height over here is going to be 4 minus 2.4. So 4 minus 2.4 is like $1.60 if I'm not mistaken. Right, so now we know that this, actually, you know what, I'll use a different color. I don't want to confuse you too much. I'm going to use blue. So that's going to have a base of 16 and a height of $1.60. Okay, so coming back to the area. So area is going to be half base times height, and we said the base was 16 and the height was $1.60. So that's going to be equal to, if I get my calculator, so 0.5 times 16 times $1.60, that should be 12.8. So we got $12.80 of consumer surplus. But if we go down a little bit, if you scroll down just a little bit to the diagram, you can see that it's measured in the quantity is measured in thousands of kilograms, not kilograms. So we're going to multiply this thing by 1,000. So really, that's like $12,800 worth of consumer surplus in perfect competition. And so what I've done is down here, I've made a note of that. So I've said, okay, consumer surplus before, so CS before is that triangle that we just calculated, and we've established that it's $12,800 in consumer surplus before the market intervention. Then we're going to introduce the market intervention. So now we're going to come back to this diagram over here, and we're going to say, but the government is going to implement a price floor, right? So once we implement the price floor, things are going to change a little bit. Rub this stuff out. Okay, so once we implement the price floor, the new price is going to be at $2.80. So it's no longer going to be $2.40, it's going to be $2.80. Remember, that's what a price floor does, right? Price floor says this is the legal minimum at which this good or service can be charged. So now the consumers, instead of paying $2.40 for per kilo of tomatoes, they now have to pay $2.80, all because of the price floor. Now we're going to calculate consumer surplus with the new price floor in place. And you can see now the consumer surplus has shrunk. Before it was kind of like that bigger triangle, and now it's going to be this slightly smaller triangle. And so to calculate the area of the triangle, once again, we take half base times height. And so to figure out the base of this triangle, if we kind of sort of scooch down a little bit, you can see that base is going to be, what is it, like 12, I think? Over here, 12? So I'm going to put down a base. This thing's going to have a base of 12. And the vertical height of this triangle is going to now be 4 minus 2.8, which is like $1.20 if I'm not mistaken. So you can see the price floor has the effect of shrinking the base to 12 and the height to $1.20. So now we do the same calculation. We go 0.5 times 12 times $1.20, and that's going to give us a consumer surplus of 7.2. But remember, because this thing is measured in thousands of kilograms, it's actually 7.2 K. Right, so $7,200 worth of consumer surplus after the price control. Okay, so, which is what I've got written down here. So we can see here that I've got the CS consumer surplus before was 12,800. Consumer surplus after is like 7,002. So to answer the question, what is the change? Remember, we've got to do this thing, right? I've got to figure out the change in consumer surplus. We'll simply take the 7,002 or the 12,008 minus the 7,002. So I'm going to go, the delta in consumer surplus is the consumer surplus before the intervention minus the consumer surplus after the intervention, which is going to be 12.8 minus 7.2, or 5.6, or $5,600, because remember that horizontal axis is measured in thousands of kilograms. So to answer the question, we would say the change in consumer surplus is $5,600 US. So 2 marker, you're probably going to get 1 mark for doing the consumer surplus before and after, and then probably another mark for doing the change in. So it's always good just to write like a little sentence just to finish off the, just to answer the question. You probably get maybe like a half a mark for writing out the actual sentence itself. Okay, so that's how we do part 3. Let's move on to the next bit, part 4. Okay, so in part 4, we're told, or asked, I guess, with reference to figure 1, explain how the price floor will impact on allocative efficiency in the market for tomatoes. Okay, so allocative efficiency refers to the kind of like the total amount of surplus that exists in a marketplace. And so by that I mean consumer surplus, producer surplus, and potentially any deadweight losses if they do exist. Okay, so to answer this question, I'm going to do this in a couple of bits. I'm going to start off by saying, what is the consumer surplus before and after? Now, we don't have to recalculate this because we already got this from part A, whatever it was before. So if I go back over here, we can see that consumer surplus before and after is like 12,008 and 7,002 respectively. This is for the price control. So we don't have to redo that bit. Just copy and paste from the previous question. Next, I'm going to figure out the producer surplus before and after. Well, actually, you know what? I'll do the producer surplus before over here. So what is the producer surplus before the intervention? Well, to answer that question, go back up to the diagram. And okay, I'm going to do a little bit. I have to do a little bit of erasing over here. Okay, so the producer surplus before the intervention is going to be given by this triangle over here. Because once again, assuming we're in a free market, then the market equilibrium is going to end up, say, at point A, which is, again, try to imagine this price control doesn't exist. So what's going to happen is that the free market equilibrium is going to be at point A, and producer surplus is going to be equal to that triangle over there. And once again, to calculate that triangle, we go area equals half base times height. Now, those of you with sharp eyes, you might realize that, hang on, this triangle for producer surplus before the price control looks a heck of a lot like the triangle for consumer surplus before the price control. In fact, they are kind of like mirror images of one another. So if you have the consumer surplus before the price control, which we do, we kind of automatically have the producer surplus because they're just mirror images, they're just reflections. So we can pretty much copy and paste the consumer surplus before, which is 12,008, and plonk it down over here to the producer surplus before, which is 12,008. So yeah, so the good news is consumer surplus before is 12,008, producer surplus before the intervention is 12,008. Deadweight loss is equal to nothing because there is no deadweight loss. Therefore, total surplus is 25.6. So we'll make a note of this, right? We'll say, okay, the total surplus that exists in the market is $25,600 or 25.6K. Then we do the after analysis and we say, okay, consumer surplus after the price control is like $7.20, which we've established from part 3. Now, producer surplus, however, is going to be made up of this weird looking thing. So what is producer surplus after the price control? Well, if you go back up to the diagram, again, I'm gonna have to do a bit of scrubbing over here. Now let's just scrub the whole thing. Okay, so after the price control, this is going to be the new price, right? P min. It's going to be stuck at $2.80. What's going to happen to producer surplus is that it's now going to take on this weird looking, I think trapezoid shape is what they call this, right? So this kind of not triangle, right? It's going to be made up of these two slices. It's going to be made up of this bit and this other bit, right? You can see diagrammatically we have that rectangle and we have that triangle. So to figure out the rectangle bit, that's pretty easy. The rectangle bit is just base times height, right? So this rectangle bit has a base of 12, and the height would be $2.80 minus $2, which is like 0.8. So this area, that's pretty easy. That's just going to be 12 by 0.8, which is 12 times 0.8, and that's 9.6. That's going to be the rectangular bit. Then we'll do the triangular bit, which is down here. Now that triangular bit, that height is going to be 2 minus, gosh, what is that? Like 0.7? Right, so 2 minus 0.7, that's going to be 1.3 in height. And the base is going to be 12, right? Because again, we dropped that thing down. We've got a base of 12. Okay, so the area of this triangle is going to be half base times height, which is a half of, 12, and the height's like 1.3. So again, if you just whip out the calculator, we've got 0.5 times 12 times 1.3, and it's going to give us 7.8. Right, so the producer surplus after the price control is going to be 9.6 plus 7.8. So go 9.6 plus 7.8, and that's going to give us a total producer surplus of 17.4. Let's go back down to our working space. So here we can see that the new producer, uh-oh, I think I've messed up somewhere. How have I messed up? Oh, right. Sorry, I misread this thing over here. This thing says, oh. I had 0.7, that's actually 0.8, right? So if you zoom in really closely, it's this annoying little doodaddies, right? So it's like 0.6, 0.7. Yeah, 0.8. So just going to make sure that you read this thing properly. So that's going to change that to 1.2, which changes that to like 1.2, and so the whole thing is going to become a half of 12, which is 6, multiplied by 1.2, which is something that my math is not good enough. Let's go 0.5 times 12 times 1.2, 7.2. Yep. Yeah, so again, just got to be careful with these little diagrams. Make sure that that you're reading them properly. As you can see, I goofed up. Okay, so the total producer surplus is going to be 16.8, right? Being the rectangle plus that triangle. Okay, but it doesn't end there. So in addition to the consumer and producer surplus, now we can also calculate a deadweight loss, which exists because of that price control. And the deadweight loss is going to be equal to, in this diagram, I'm going to use the color black. Typically, people use black for deadweight loss because it's like a bad thing. Right? It's like a loss to society. So the DWL is going to be equal to that triangle over there. I'm not going to bother doing the calculation for the triangle. Suffice to say, it's like 1.6, I think. So you can verify this if you want. Yeah, it's just two right-angle triangles that you just add together. Right, so the deadweight loss is going to be 1.6. Right, so to answer the question, this is what I've written. I have said look, the total surplus before the price intervention or the price control is 25.6. The total surplus after is 24 with a day weight loss of 1.6. Now, allocative efficiency implies that total surplus is maximized. Since total surplus has fallen and dead weight loss has risen after the price floor is not allocatively efficient. So yeah, or something along those lines, right? As long as you can demonstrate that flow of logic, then that should be enough to get you your 4 points. So this thing is worth 4 points. Probably get like a couple of points for calculating the consumer surplus, producer surplus, and the dead weight loss before and after the price control. And you probably get like another couple of marks for explaining your rationale. Now, you don't have a lot of space. As you can see, I'm kind of squishing. You don't really have a lot of space to do this, so just be careful that you kind of plan this thing properly. You do have some scrap paper that you can work with, so make sure that you plan this thing properly before you write your answer, because otherwise you don't want to end up running out of space like I have over here. Yeah, so that's how I would grade this particular question. Okay, so let's move on to part 5. Now, part 5 is asking us to calculate the indirect tax paid by the airlines for the catering meals they bought in 2021 if the domestic indirect tax rate on food is 6.5% and the expenditure on meals was $54,506.70 or whatever. Right. So they're asking us basically how much tax is, so calculate the tax paid, right? That's what you gotta do. You gotta figure out how much tax these guys are paying if the government levies a 6.5% tax on food and they spent $54,000 in total on food expenditure, in that particular year. Right, so the way we do this is we do this. We start by saying the formula for expenditure after tax is equal to 1 plus the tax rate multiplied by the expenditure before tax. Now think about this, right? If I charge you a tax on something, then you have to pay the original price plus whatever tax that's levied on, right? Hence the formula we have 1 plus the expenditure after tax is 1 plus the tax rate multiplied by the expenditure before. So imagine if I put like a 6.5% tax on a thing, you were spending $1 before, now you got to pay $1 plus that 6.5%. So that's why we have this 1 plus the tax rate multiplied by the expenditure before tax, right? That's where this formula comes from. Okay, so once we have this formula written down, the rest is actually pretty simple, because all we have to do is just do some substitutions and kind of fill in the blanks. So in terms of the tax rate, we're told that we have a 6.5% tax rate. So I'm going to substitute that into that 6.5%. That's going to go into the formula in a second. And also we're told that we're spending $54,000 blah, blah, blah. So that's going to go into the expenditure after tax. And so that's going to flow into the next line. You can see that now we've got 54,506 is equal to 1 plus 0.065. Remember, 6.5% is 0.065 in decimals multiplied by the expenditure before tax. So all we're going to do then is we're going to take this guy, and we have to do a bit of algebra to rearrange the equation so that it appears on the left-hand side. So one thing we could do is we can just kind of divide both sides by this guy 1.065. If I just boot this over to the left side, that should solve my problem. So if I divide both sides by 1.065, we're going to end up with expenditure before tax. So that's going to go down to the next line. Expenditure before tax is going to be 54,506 divided by 1.065. Remember, we're dividing because we want to undo the 1.065 bit, yeah? So divide by 1.065. So if I get my calculator out, 54,506.7 divided by 1.065 is going to give us 51,180, which is this number over here. And that's going to give us the expenditure before tax. Now, we're not out of the woods yet, right? Because we still haven't answered the question. The question is asking us to figure out the total amount of tax that is being paid. So to figure out the tax that's being paid, we simply go, so sales tax paid is simply what we paid before, how much we paid after tax minus what we would have paid before tax. So assuming that no tax exists, we would have paid 180. After tax, we're paying 54,506. So the delta, or the difference between those two, is the $3,326.70, and that is the total amount of tax that we've paid on this particular thing. All good? Excellent. Let's move on. Okay, so in the next part of this question, we've got some tables and stuff about CO2 emissions and whatnot. So let's have a quick read. The information that follows refers to the aviation industry, which is considered a significant contributor to global warming and climate change. Okay, table 2, this shows us the energy used and the CO2 emissions for rail and air travel. So if you go by train or if you go by plane, if you go by train, you can see that we would be using 1.387 millions of joules per passenger kilometer. And if we go by air travel, that's going to cost like 1.576 megajoules per passenger kilometer. And if you go by train, in terms of CO2 emissions, we're getting like 0.085 kilograms per CO2 emitted per passenger kilometer, whereas for air travel, that's 0.156 kilograms of CO2, etc. Right? So I've got a whole bunch of these things, a whole bunch of information that follows them down here. We've got we've got a table on price elasticity of demand and income elasticity of demand for leisure and business travels, etc. I'm guessing we're going to have to come back to this table in a moment. So let's keep going, because I just want to figure out what we have to do. Okay, so here, this is where the question begins. So question 1, part 5 is asking us to, what do we have to do? So I'm just going to highlight this question first. The impact of a 4.5% rise in the price of airline tickets on the quantity of leisure travel demanded has been calculated to be minus 10.26%. Using the figures in table 3, calculate the impact of the same 4.5% rise in the price of airline tickets on the quantity of business travel demanded. Okie dokie. So what we're saying is prices are going to go up by 4.5%. for airline tickets, and we have to figure out the impact on the quantity of demand for business travel, right? So price go up by 4.5%, and quantity demand is going to go down by some unknown amount. So how do we figure out the impact of that 4.5% price rise on the demand on the quantity of demand for business travel? Well, that's where elasticity comes in, because that's precisely what elasticity does. So we write the formula for elasticity. So elasticity is equal to percentage delta Q divided by percentage delta P. Now, we know that the price has changed by 4.5%. So that's going to be percentage delta P. It's going to be 4.5%. The elasticity, we actually get this from the table above. Remember, we're trying to find the price elasticity of demand for business travel. So let's go back up to the table over here. And what we have, lo and behold, is the price elasticity of demand for business travel, which is minus 0.34. So let's go back down here. So that's going to get a negative 0.34. So we substitute those values in, and now we end up at the next line, which is over here. Minus 0.34 is equal to percentage delta Q divided by 4.5, and we post-multiply both sides by 4.5 just to get the delta Q on itself. And so now we have delta Q is equal to minus 3.4 multiplied by 4.5%, which is minus 1.53%. So to answer the question, the impact of the 4.5% rise in prices on the demand for business travel is minus 1.53%, right? So you raise prices by 4.5%, and you're gonna reduce the demand for business travel by 1.53%. That's how you'd answer that question. It's only 2 marks, and so that's like a straightforward application of the elasticity formula, and all you gotta do is just fill in the blanks, as you saw. Okay, so nothing too thrilling. Let's move on to the next bit. Now the EIU is predicting that between 2020 and 23, global incomes will rise by 3% on average annually. Using relevant information from Table 3, describe the expected impact this rise in global incomes will have on the demand for domestic travel in relation to the demand for international routes. Okay, so what are we saying? So we're saying that incomes are going to rise by 3% per year on average, and we have to figure out the impact on the demand for domestic routes and the demand for international routes. So what information do we have in Table 3 that could help us? Well, we have income elasticity of demand for domestic travel and income elasticity of demand for international travel. So the income elasticity of demand for domestic is 1.1186, and the income elasticity for international is 1.546. So I've split this up into two bits. So I've got the domestic travel, which is over here, and then I've got the international travel, which is, as you can see, right next to it. So let's do the domestic travel bit first. To figure out the impact of this income growth on domestic travel, we first, I guess, write the formula for income elasticity. So YED, income elasticity, is the percentage change in quantity divided by the percentage change in, now that shouldn't be price, I guess, that should be change in income, if we're being like really pedantic, right? So that should be percentage delta I guess. But whatever, I don't think anyone's gonna like fuss too much about that. So the percentage delta I, the change in income, that's gonna be 3%. Now, the income elasticity for domestic travel, we're gonna get that from the table above, which we said was 1.1186. So this is gonna be this thing here gonna be like 1.1186. And so we substitute those values in, and so we arrive at the next line, which is over here. So here we see that 1.1186 is equal to percentage delta Q divided by 3. And so we do a bit of a bit of rearrangement to get percentage delta Q. So on its left-hand side, so to do that, we multiply both sides by 3. And we end up over here. So the percentage delta Q is 1.1186 multiplied by 3, which is going to give us 3.3558%. So we're saying that if incomes were to rise by 3%, then that's going to lead to a 3.3558% increase in the demand for domestic travel over time. That's that bit. Now we're going to do the same thing, but now we're going to do it for the international travel. So again, we'll plonk in the 3%. That's going to go into this thing down here. That's the growth in income. And again, I'll just fix this up a little bit. I'll use like delta I for income. And then we've got to figure out the running out of space. Okay, we've got to figure out the income elasticity of demand for international travel, which we can get from Table 3. Which is over here, 1.546. So let's write that down, 1.546. And so we sub the values in, and we end up with 1.546 is equal to percentage delta Q divided by 3. Again, we multiply by 3 on both sides, and we're going to get percentage delta Q is 1.546 times 3, or 4.638%. So if you raise incomes by 3%, you're going to get a 4.638% increase in the demand for international travel. Right, now I think about so the question is asking us to I guess analyze the impact of that, right? So it would say something like, since the percentage change in percentage delta Q for international travel is greater than the percentage change in quantity demanded for domestic travel, higher incomes will have more impact on international travel, or something to that effect. So yes, you get a couple of marks for doing that particular question. Again, nothing too dramatic. I think the main thing is that you'll probably get like most of your marks for doing the income elasticity calculation over here for domestic, and for international travel, and you might get like a half a mark just for answering that question. Okay, so if we move on to the next question, so part 8. The information on page 6 strongly suggests that the aviation industry is responsible for significant market failure. Using this information and an appropriate diagram, explain the market failure the aviation industry creates. Okay, so here we've got a very typical market failure type of diagram. The market failure diagram kind of depends on the type of market failure that we're looking at. So in this case, I think it's going to be a negative externality because we're talking about CO2 emissions. And that's going to be typically like a supply side problem. So the market failure here is going to be a misalignment between marginal private costs and marginal social costs. So the way we do that is we start by sketching our demand curve. So call this D, and this can be sort of, I'll just call it D for demand. You know what, if you want, you can just write marginal social benefit, marginal private benefit. Here, there's no misalignment between private benefit and social benefit. Then I want to sketch in the marginal the supply curve, which is the marginal private cost, and we're going to sketch in the marginal social cost curve, which is like over here. And I'm going to draw a couple of points. I'll call this point A, and drop this down. We'll call this like Q1, and I'll have the second point over here. We'll call this point B. At the intersection between the marginal social cost curve and the demand curve, drop this thing down, and we'll call that like Q star or something, which is like that socially optimal quantity of demand. Okay, so to explain the diagram, what we have here is we have our demand curve, right? That should be pretty evident to you. We have a normal supply curve, which we call the marginal private cost curve. But then in addition to this, we also have this thing called a marginal social cost curve, which sits above the marginal private cost curve to indicate that because of the negative externality, the social costs are actually greater than the private costs. And were you to leave things to the free market, then what's going to happen is that the free market will consume at point A, and we're going to end up with Q1 amount of this good being produced or traded, whereas ideally where we should be at is at point B, and the market would be producing Q star. So because the market's going to behave according to private costs, not social costs, we're going to be like permanently stuck at point A, and at this point you can see that the amount that's being produced is Q1, which is greater than Q star, so that the market, if you leave things to the free market, private market would end up overproducing this thing, and we have to find a way to cut the production back to Q star, which is the socially optimal quantity. So that's the diagram, and to explain the diagram, you would have something like this, right? So something simple, I would say like under free markets, equilibrium will occur at point A. The quantity of air travel is Q1, however, the socially optimal quantity is Q star, which is given by the marginal social cost curve, or MSC. Since Q star is less than Q1, free markets will result in more air travel than the socially optimal quantity, right? To end up with overconsumption of this thing under free markets. Cool. Let's move on to the next bit. All right, so this is the walker, right? So using the text/data provided and your knowledge of economics, recommend a policy that may be implemented to reduce the contribution of emissions to the aviation industry makes to global warming. Okay, so this is kind of like the fluffy bit where you can kind of use your imagination or whatever, and you can sort of score a few free points if you're able to explain yourself well. Okay, so there's really no right or wrong answer here. I mean, well, there is a set of I wouldn't say there's no right or wrong answer. I would say there's a list of kind of accepted things that you can talk about. All right, so I'd start off by saying the problem is due to a misalignment between private and social costs. Therefore, the solution is to force industry to internalize social costs. Some policies include. All right, so from here you would say, okay, these are some of the policies that government can implement, or things that we can use as a society to try to reduce or discourage that overproduction or that overconsumption, and to to realign that private and social cost. So in terms of the supply side policies, we can use, for example, like a carbon tax. So by levying a tax on carbon emissions, the marginal private cost curve is shifted up to the point where it is equal to the marginal social cost, or MSC curve. The amount of air travel will reduce to Q star, which is the socially optimal level. So what we're saying is here, if you were to put a supply side tax on, then that should be enough to raise the marginal private cost curve up to the level of the marginal social cost curve, and in doing so, you naturally cut the level of consumption from Q1 down to Q star. So that's the case of a carbon tax. Now, another policy would be to use like a quota or some sort of cap and trade arrangement. So under a quota, I've written, under this scheme, governments issue permits which give industry pollution rights. The costs of these permits are determined via auction. Generally, it has the same impact as the carbon tax. By raising the marginal private cost to the level of marginal social cost, firms are forced to internalize their negative externality, and quantity decreases to Q star. So yeah, or something to that effect. Now, mind you, you don't have to do every single one of these, by the way. The question is only asking you to like provide or recommend a policy, so I'm giving you like more than what you need. So don't freak out if you think, oh my God, I'm never going to be able to reproduce this in an exam condition. You don't have to. You only have to remember like one or two of these things and have enough contextual knowledge to be able to explain your position in the assessment condition. Okay, another strategy or another potential policy would be to remove fuel subsidies. If airlines receive fuel subsidies, this reduces their costs and the supply curve shifts out. By removing these subsidies, the supply curve shifts back and quantity of air travel decreases. Well, that's another option that's available to government, which is if your airline sector is getting fuel subsidies, well, don't. Just don't subsidize them. And that's naturally going to make things more expensive. And so therefore they'll pass those costs on to the consumers and demand will naturally cut back to a more sort of socially optimal quantity. So that's policy number 3. Now the next and final policy I can think of is on the demand side. So here we say, well, those were 3 supply side policies, but if you want to focus on the demand side, you can also consider doing something like subsidizing green forms of transportation. Other forms of transportation, such as rail or bus, may be better suited to electrification, thereby producing less carbon emissions. By subsidizing these alternatives, consumers may switch away from air transport and quantity decreases to Q star. So here we're saying that, look, on the demand side, there could be other forms of public transportation that might produce fewer carbon emissions. So if we had, for example, had electric buses or electric trains, these would be better than using sort of air travel, which at the moment electrification isn't really feasible because I think the batteries are too heavy and so the planes can't really fly. But we don't really have the same problems for trains or buses. So if you subsidize these alternative forms of transportation, you're going to make it more appealing for consumers to use those forms of transportation, and so they'll naturally switch away from air transportation to rail or bus. Okay, so there you have it. So that's it for question 1. I'll do question 2 in the next video. So hopefully this was useful to you guys, and I'll catch you in the next one. See ya.